that's okay. All right. Make sure I'm not muted. That would be bad. Yes, we've been building up to the unit circle. It is going to be uncomfortable for a couple days, and it's going to feel like I'm pushing you faster than you want to be pushed, and that's okay. Almost everyone gets there the first attempt at our gateway. We will take a gateway as many times as you need to, because it is so important to move forward from here that you know your unit circle. We will, after taking, okay, so let me back up. I keep saying this word gateway at you, and you may not know what that means. It's similar to like a DCA, but you're just going to take the gateway until you made a certain cut score. And we will take it first on Tuesday. I think I have my days right here. And my incentive for you to pass it the first time around is if you meet the cut score on Tuesday, I'll give you 100%. Whether you got 100% or not, if you meet the cut score, you get 100%. Everyone will take it twice. If you either beat your score or get 100% at the second time, I will give you a bonus point as well. Okay, so there's your incentive for doing well twice. I have versions A through F of the gateway. Please don't get to F. Okay, but you will keep taking it until you pass, until you meet the cut score. Detail orientation is going to be important because having the wrong sign on your problem is half of the point. So paying attention to whether your answer is positive or negative becomes very important. All right, jumping into this idea of the unit circle. Why does it have the name unit circle? It has the name unit circle, and this is a kind of picture of like a generic one, because the radius is a standard length of 1. So they have taken it and they make it 1 unit of whatever it is. It doesn't matter, but the radius equals a value of 1. So what that does is it takes a lot of these things that we've been using and it forces the radius to be 1, which then alters the lengths of the legs of that right triangle that we've been working with. Okay, so that's where we're going to kind of start this. By the end of today, I am going to give you 3 methods for how to memorize your unit circle. You are going to pick the method, and you have to pick a method. You're going to pick the method that you think is going to work best with your brain, and you're going to get really good at it. I will tell you the one that I prefer. It is not the one that works best for everyone. So pick the one you like. I can teach all 3 of them. Okay. One of those involves our right triangle. So my introduction to the unit circle, showing you the right triangles, that is kind of method number 1. If you are like super good at visualizing those special right triangle models that we've been using, this might be the method for you. Okay. But what changes about your model in the unit circle is that as I draw that 45, 45, 90, my hypotenuse has to be 1, which changes then the lengths of the sides. So going back to our model, now our model earlier said 1, 1, and 1 squared of 2, but it's any multiple of that. Whatever the length of the leg is, you multiplied it by the square root of 2 to get your hypotenuse. Okay, so what if I force our hypotenuse to equal 1? Then how did that alter the lengths of the legs so that they still have that relationship, okay? So let's just do some quick algebra. Okay, if I want to know what x is, the length of my leg, I would solve for x. And we get this whole 1 over the square root of 2, which I would rationalize and get that the length then of our legs is the square root of 2 over 2. So that's where this number is going to come from. So in a 45, 45, 90 drawn into the unit circle, meaning again, our radius has to be 1, then each of the lengths of the legs would be the length of square root of 2 over 2. So if you are a special right triangles person, instead of thinking of your model being 1, 1, and 1 square root of 2, I would now picture my model being this. I'm just going to draw it a little bit bigger. Picture my 45, 45, 90, or my pi over 4 model to be 1, the square root of 2 over 2, and the square root of 2 over 2. Okay. In your 30, 60, 90, again, my hypotenuse has to equal 1 when I put it into the unit circle. So if this is now 1 instead of 2x, 2 times the length of our short leg, that means the length of the short leg across from that 30-degree angle, show you my algebra here, is 1/2 instead of 1. So instead of going 1 and 2 and the square root of 3, it's going to go 1/2, 1, and then put that 1/2 here, 1/2 times the square root of 3, which ends up looking like the square root of 3 over 2, multiply straight across the top, straight across the bottom. Okay. Now that one can be flipped because the 30 could be at your origin, or the 60 could be at your origin. It doesn't matter. It's the same side lengths. You just need to make sure that the correct number is across from the correct angle. But again, instead of thinking of it as 1, 2, and the square root of 3, now if I am going to stick to being a special right triangles person, degrees or radians are the same thing, right? I would now think of my model instead as being a hypotenuse of 1, short leg of 1/2, and my long leg of being the square root of 3 over 2. So it's the same special right triangles we've seen all along, but the hypotenuse now has a length of 1 specifically because it's in the unit circle. Questions so far? Okay, so that is going to be the foundation for method number 1, is if you want to draw this triangle based on what your reference angle would be, and think through, okay, then what's my opposite adjacent hypotenuse, or whatever I need for that particular trig function they're asking me for, there you go. If you're comfortable with those, if you're really good at those, use special right triangles. Okay, so what does that do then in our unit circle? So what happens in your unit circle is they have taken it and they've broken it into those same angles that we've been seeing a lot of intro to, is they break it into thirds, fourths, and sixths, because that's what goes with our special right triangles, okay? Think about if I were to break my circle into thirds, take like 180 degrees, right? And break it into 3, 180 degrees divided by 3, means I would be looking at like 60 degrees, right? Or 120 degrees, 180. If I go another 60 degrees, you'd be looking at 240 degrees. Another 60 degrees would be 300 degrees. These are really not those angles. You'll notice that there falls 1 in each quadrant, right? See that? Okay. Or 0 or 360, but again, that's not in a quadrant. In radians, what if I were dividing it in thirds? So again, take that pi, divide by 3, we get pi over 3. So in radians, this would be like a pi over 3 angle. In quadrant 2, or another third, that would be 2 pi over 3. 3 pi over 3, which is pi again, not a third because it simplifies. Add another would be 4 pi over 3. Add another would be 5 pi over 3. 6 pi over 3 is 2 pi, which again doesn't have a third under it anymore, so we wouldn't consider it on all of these. But what angle are we looking at? We're looking at a 60-degree angle, or a pi over 3 angle, which means if I were to connect all of this, we would be using our 30, 60, 90 model, right? And in your 30, 60, 90 model, with your hypotenuse being 1, your side across from the 30 degrees is 1/2, and your side across from the 60, which is this vertical line, being the square root of 3 over 2, the ordered pair that gets us to this point right here would be to the right 1/2, up square root of 3 over 2. Oops, square root of 3 over 2. And then what happens is that's the same directions I need to get to all of those points. Insert in negatives or positives to get me to the different quadrants, because notice it would form the same right triangle. If I drew the right triangle this way, it's still a 60 degrees here because it's 60 degrees away from 180, right? But I went left 1/2 up square root of 3 over 2. So notice all of these will have that exact same ordered pair, but change the positives and negatives to move us to the different quadrants. That's when our angle at the origin is 60 degrees, or we have divided it into thirds. Questions? Okay, so let's look at fourths and sixths. When we do fourths, so taking 180 degrees divided by 4, if I were to do that, what you will notice is 180 divided by 4 is 45 degrees, or pi divided by 4 is pi over 4. And so as I look at that, first of all, we do pay attention to what simplifies. So yes, I would have 1 pi over 4. This is 2 pi over 4, but it would never stay as 2 pi over 4, right? Which is why we're not actually going to see that one in our fourths, because it would be pi over 2, which no longer has a 4 in the bottom, right? Kind of like the pi on the last page. So that was 2 pi over 4. So this would be 3 pi over 4. 4 over 4 is just 1 pi. 5 pi over 4. And again, the 6 pi over 4 would not stay 6 pi over 4. We've seen it already. It's 3 pi over 2, right? Seven pi over 4, and then 8 pi over 4 is 2 pi. And what happens is those are, well, I guess I didn't do degrees yet, did I? 45 degrees, 90 would be up here. It's on your axis. Add another would be 135, 180, 225. Oops, not in parentheses. 270 and 315 degrees. So these are all the angles that would share the same triangle to get to, and that is an angle here, a reference angle that we learned about yesterday, right? All have the same reference angle, meaning if I draw this triangle in here and I see that my reference angle is that 45 degrees or pi over 4, we've now made in the unit circle, my hypotenuse has to be 1, which makes each of these side lengths square root of 2 over 2 and the square root of 2 over 2. Okay, so to get here, I go to the right, square root of 2 over 2, and up square root of 2 over 2. And if I move it to a different quadrant, we just use the same point, but change the positive negatives. Still good. Okay, and then the last one we need to see, and there's a lot of simplifying that goes on in here, is that if I were to do this in sixes, first of all, 180 degrees divided by 6 is 30 degrees. So every one of those little lines is adding another 30 degrees. Or pi divided by 6 is obviously pi divided by 6. Now I'm going to erase a whole bunch of these because we've actually already seen them. But if I go, it'd be 30, 60, 90, 120, 150, 180, 210, 240. I'm just keep adding 30 each time. Okay, now thinking back on what we've already seen 60, we've already seen 90, we've already seen 120, 180, 240, 270, and 300. The ones we have not seen are the 30, 150, 210, 330, and they all have that same reference angle of 30 degrees, right? So they'll all share this same point. In radians, pi over 6, now this would be 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 over 6, right? 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and our full circle of 12 pi over 6. However, most of those simplify to a different number, right? Instead of 2 pi over 6, that's what we already saw, pi over 3. This would be pi over 2. This would be 2 pi over 3, right? Which is why they are not the same as the sixes. This one would be pi, 4 pi over 3, 3 pi over 2, 5 pi over 3, 2 pi. All the ones in green we've already seen on another page or are on an axis. They don't share the same reference angle of 30 degrees or pi over 6. So if I draw in my triangle now here with a reference angle of 30 degrees here, label at 30, 60, 90 the way we now know. That means I move to the right, square root of 3 over 2, square root of 3 over 2, and up 1/2. Now, those 3 points that I just showed you make up 90% of the unit circle, because it is all of your angles here in every quadrant. The only ones we have not talked about and will not get to until the end of today is when they fall on an axis. So you've seen every answer we can get minus what we will find on an axis, which you actually already have an intro to. Okay, so think about what's going on here. As we look at this, before I go to this picture, look at each of these triangles. Now that I have made my hypotenuse 1, the two main trig functions that you are going to see, sine and cosine. So if I use this one as my sample, sine is your opposite over your hypotenuse. But do you see what the hypotenuse is? 1. So when I do my opposite over the hypotenuse, dividing by 1 is not going to change anything, and it ends up being that my sine is my opposite side, which will always be your y. And so what we're going to find out is our sine is always our y value in that ordered pair. It's easier to see in this picture. Now, if you choose to do special right triangles, that is not something you need to memorize, because you can still see that opposite over hypotenuse would simplify to that. But I just want to show you as we have a picture going on here. Oops, that's not my hypotenuse. It's my adjacent. So then if I think cosine, my adjacent side over my hypotenuse, again, my hypotenuse is 1, and I would divide by 1, and so that I would just get the square root of 3 over 2, and you notice that that is my x value in that ordered pair. Okay, so enter in now method 2. Method 1, draw those right triangles for whatever your reference angle is. Think through SOHCAHTOA. Method 2 for learning your unit circle is to memorize quadrant 1. Once you know quadrant 1, you know all of the quadrants, because all you have to do is change the sign on either your x or your y value. Okay, so what was quadrant 1? If I put all of that together, going small to big, my angles would be a 30-degree angle, a 45-degree angle, and then the biggest one was a 60-degree angle. In radians, that would be my smallest angle being pi over 6, my middle angle being pi over 4, my biggest is pi over 3. And those ordered pairs then that we had spread out on those 3 different pages would be the square root of 3 over 2 comma 1/2, square root of 2 over 2, square root of 2 over 2, and 1/2, square root of 3 over 2. Now, initially that looks like kind of a bit to memorize, but what I want to point out is if I consider all of the numerators to be the square root of the number, because the square root of 1 is 1, and all of those, notice every single one of them is over 2. You see that? Every single one of those numbers is over 2. Look at your numerators. They go 1, 2, 3, 1, 2, 3. So could you reproduce that picture for yourself at the top of your assignment and kind of reference it each time? Maybe that's your method. Okay, if you like that, memorize what quadrant 1 is and how you can kind of draw this picture for yourself each time you go through unit circle values. Okay, now with that being said, then you need to know that each of those ordered pairs, as we showed on the last page, will go cosine value, comma, sine value. And I will say this like a bazillion times in the next 2 weeks, alphabetical order, cosine, comma, sine. Okay. And then the last thing to finish out all of this is to get all 6 trig functions, you will need to know that tangent is your sine value divided by your cosine value. Now, if you choose to do this method, tangent ends up being a little bit of extra work for you. You'll get used to it, and you'll notice that we have a repeated answer over and over and over and over and over, and you'll be able to jump to those answers without showing as much work each time eventually. Okay. So let me give you 2 quick examples on this. If we're talking like quadrant 1, let's say like if I asked you for the sine of pi over 6, in this method, I would have drawn this. I know that sine is the second value. My answer is 1/2. If my question was, what is the tangent of pi over 6? Then I have to take my sine value divided by my cosine value. And just again, a quick preview, if this is the method you pick, my sine value is 1/2 divided by my cosine value here. And this is where you would learn to speed things up. Dividing by a fraction, I would multiply by the reciprocal. So I would end up with, well, my 2's can cancel, can't they? 1 over the square root of 3, which is ultimately the square root of 3 over 3. Okay, questions so far. So there is method 2. Memorize quadrant 1, know that the ordered pairs go cosine comma sine, and that tangent is your sine value over your cosine value. Well, people are kind of getting this one, again, copied down into their notes. If I were to have gone back to method 1 for this, I would have thought of, okay, well, what does the special right triangle with the pi over 6 being my reference angle look like? What is my opposite over hypotenuse? Okay, so there's your special right triangles. Okay, now, method 3. Method 3, was that me? Okay, thank you. Method 3 is one that is a little controversial in the department. Depends on what teacher you have. Some people think it is too gimmicky. I personally love it. So you make your own decision on what method you like. The last is a hand trick, and I just like it because you have it with you all the time. Okay, I don't have to draw anything, but it's specifically the left-hand trick. And if you get done this weekend and you're like, I can't remember this, it is all over YouTube. You can like go search the unit circle left-hand trick and watch somebody else talk through it. But it is your quadrant 1. What it turns out is your hand makes a great quadrant 1. If you look at the palm of your left hand, there's my x-axis and my y-axis. And then there's those angles we just had on the last page. 30 degrees, 45 degrees, 60 degrees. Okay, it very nicely has all of those angles in there. So if here's my hand, this is my x-axis, this is my y-axis, and my fingers go just like we saw on the last page, 30, 45, 60. So that's part of it. You have to remember which finger's which, right? But picture your quadrant 1 right here. Or pi over 6, pi over 4, pi over 3, okay? And in your hand trick, what you will do is instead of finding the picture of your ordered pair, my hand will create that. So what I do is I say, okay, what is the question? What is my reference angle here? Pi over 6. Okay, well, that's this finger. You pull back your reference finger, and it breaks your hand into top fingers and bottom fingers. You see that? Got fingers above my reference finger and fingers below my reference finger. And so what your hand trick is that it is always the square root of your fingers over 2 in alphabetical order. So you've got cosine fingers, comma, sine fingers. Square root of 3 over 2, comma, 1 square root of 1 over 2, 1/2. I just gave you this ordered pair. Square root of 3 over 2, square root of 1 over 2. Okay, there's quadrant 1. Square root of 2 over 2, square root of 2 over 2. Square root of 1 over 2, 1/2. Square root of 3 over 2. Okay, so you can just pull back your reference finger and it will visualize that quadrant 1 for you if you remember, and that's where the little gimmicky part of it is. If you remember that your ordered pair goes the square root of the top fingers over 2, comma, square root of the bottom fingers over 2. Cosine fingers, comma is your reference finger that you pulled back. Sine fingers. Now that part is not as, it is nice. I like that part of it. Tangent is really nice, but again, tangent is a little gimmicky to start with. Bear with me here. So I told you that it was cosine fingers over sine fingers, right? Cosine, comma, sine. Well, if tangent is supposed to be sine over cosine, I turn my hand upside down, and now it is sine over cosine. Or you look at the side of your hand that tans when you do your tangent, okay? So tangent for hand trick is you look at the back of your hand. You pull back your reference finger. You look at the back of your hand. And then here's what makes it a little bit better than the other methods because there's not a lot of work to do. It is your square root of fingers over square root of fingers. So if I do tangent of, let's say, 60 degrees, I pull back 60 degrees. I look at the back of my hand. It would be square root of 3 over square root of 1. So we do sometimes still have some simplifying to do. Let's go back and do this one. Tangent of pi over 6 would be here. Here's pi over 6. Look at the back of my hand. It basically jumps me to this stage right here. Square root of 1 over square root of 3. Questions? And then you would simplify that. Okay, now it is a getting used to one of these methods. Here's the deal. I will show the special right triangles one. I can show, well, actually I can show all three. You know what? We'll show all three real quick. Each time you pick the one as I'm going through them. Ooh, that one made more sense to me. That's when you're gonna get really good at this weekend, okay? So the important part is the thought process of these first couple questions, which is not gonna mean much to us right here on this one because of where it's located, but every time you have to think through this. This is why we are building up to this. What is the reference angle? Well, to do this, the easiest thing is to draw it. So start by drawing a picture of 45 degrees, okay? The picture will help us with those first two questions. What quadrant is that in? 1. What's my reference angle? 45, right? If we are in quadrant 1, is my answer going to be positive or negative? Positive, it doesn't even matter what the question is, right? Because in quadrant 1, all students take calc, all things are positive, so my answer is positive. Okay, let's run through the three options. Option 1, I draw the special right triangle that has that as my reference angle. If this is the method you pick, I would start by just having that picture on the top of your page. You're not going to draw that every problem, right? And then I say for myself, okay, what is sine? Sine is opposite over hypotenuse, square root of 2 over 2 over 1, which is square root of 2 over 2. If my option is to think, memorize quadrant 1, I would have this drawn on my picture. I would be focusing on 45 degrees, which is this one, which has an ordered pair sitting here, square root of 2 over 2, comma, square root of 2 over 2. And my answer would be the second one because that is our sine value. If I pick method 3, it's hand trick. So hand trick, I go, my reference angle is 45 degrees, which is our middle finger. We pull middle finger back. It goes cosine fingers, comma, sine fingers. I have 2 sine fingers, and it is always square root of fingers over 2. So square root of 2 over 2, my answer, regardless of my method, square root of 2 over 2. I understand that it is very slow for me to talk through these right now. They will be quick problems eventually, okay? Bear with me. Any questions? Okay, answer the first couple questions. Draw it. Where is it? What's my reference angle? Is my answer positive or negative? The fact that this is a negative angle does not mean my answer is negative, right? That is completely, my answer positive, negative is completely from all students take calc. So if I were to draw negative 120 degrees, do we all get a picture something like that? So we are in quadrant 3. Oh, that's about row to 2. We are in, and I put a 2. We're in quadrant 3. My reference angle, how far am I from our closest x-axis? 60, right? My closest x-axis would be 180. We are at 120. That means that I am 60 away from that. And is my answer positive or negative? Quadrant 3, all students take calc. We are doing a cosine problem. Negative. The only thing that will be positive here is if I were doing a tangent problem. I am not. Okay, so if I pick to draw my special right triangle, I am going to pick the one that has a 60 degrees as my reference angle. And I have to remember what that model looks like. If I pick to memorize quadrant 1, I would be right now focusing on the 60 degrees and knowing what that ordered pair is. Cosine being my first answer. If I choose to do hand trick, I would pull back a 60-degree reference angle, which matches that first quadrant. It goes 30, 45, 60. And my fingers go in alphabetical order. Cosine, comma, sine, square root of fingers over 2. So I have 1 cosine finger, square root of 1 over 2. Regardless of our method, oops, before I circle that, we are in quadrant 4, so I tack a negative on it. Some people expand this if they draw it. Some people will draw a special right triangle for every single problem and draw it into the correct quadrant. That's fine. You can do that. That's a lot of work and a lot of drawing, which is fine. Questions? Are you starting to find a method you like? Yes. For hand trick? This one? Yeah. Cosine. So remember your ordered pairs go cosine, comma, sine. And our first one in that particular ordered pair is 1/2. Yes. Other questions? Okay. Next one. Draw the angle so you can visualize where it is. We are looking at a negative pi over 3. For too far. We're only 1/3. 1/3 is going to put us into, yep. All right. Negative pi over 3. You should have drawn into quadrant 4. My reference angle is, ooh, this is why we love radians. Because our reference angle is easy. Pi over 3, right? Pi over our denominator. So my reference angle is pi over 3 in quadrant 4. And we're doing a cosine problem. Is my answer positive or negative? Positive. Even though the question had a negative in it, remember that does not impact the answer. Sine. All students take calc does, right? Okay, let's go through our methods. I'm going to do hand trick first so you can't see what I've got up there. Hand trick first. Remember, small to big, 1/6, 1/4, 1/3 would be small to big, or pi over 6, pi over 4, pi over 3. There's my reference angle. It goes alphabetical order. Cosine fingers, comma, sine fingers. I have one cosine finger, and it always goes square root of fingers over 2. Okay, yes. Other methods. Let's go backwards. So we'll do memorize. That's the same ordered pair we just saw on the last page. I called it 60 degrees on the last page. It is the same as pi over 3. That ordered pair goes 1/2, comma, square root of 3 over 2. Cosine is your first number, alphabetical order. Cosine, comma, sine. Answer still 1/2. Or I draw myself a special right triangle model, remembering that pi over 3 is the same as 60 degrees. And cosine is adjacent over hypotenuse. Questions? Okay. Let's do a tangent problem. We haven't done a tangent problem yet. Today we are going to focus on only sine, cosine, and tangent. Monday we will add in their secant, cosecant, cotangent once we're good at this. And also, if it ends up being bigger than a full circle, what we do. So let's get the basics figured out here. Okay, draw me a 7 pi over 6 picture. And I'm going to have a quick conversation about radians. Remember, and I'm going to erase this, but remember we always do 6 over 6 and 12 over 6. Guys, when you are drawing, and hopefully you've now recognized this and why our reference angle is always going to be pi over the denominator, you can only ever be 1 away, or it would have simplified down to a different number. Okay, so if you are 1 less than this, you would stop short and be in quadrant 2. If you are 1 more than this, you would go just past it and be in quadrant 3. Similarly over here, if I'm 1 short of that, 11 pi over 6, I'd be in quadrant 4, or 1 pi over 6. Those are really your only options. You're only ever 1 away from the axis. Am I 1 short of the axis or 1 past the axis, right? Does that make sense? Same thing with 4s and 3s. It's the same thing. You're always only 1 short or 1 more than an axis, which is why our reference angles are easy to find. 7 pi over 6 then should have put us just past half a circle into quadrant 3. In quadrant 3, the only thing that is positive is tangent, which happens to be the problem we're doing, right? So my answer will be positive. And my reference angle, why we love radians, pi over 6. Okay, again, I'm going to do hand trick first, and then we'll work our way back to special right triangles. If I do hand trick, this is the key on hand trick. For tangent, you have to do your reference angle first. Look at it like normal, find your reference angle. Remember, it goes small to big, 1/6, 1/4, 1/3. So small to big, pi over 6 is here. There's my reference angle. For tangent, now I turn my hand over, and I do square root of fingers over square root of fingers. So square root of 1 over square root of 3. And here's what's going to happen is a lot of you are going to see these enough that you're going to look at your hand and jump to our rationalized answer, because it's not going to, there's only 3 options. Square root of 1 over square root of 3, square root of 2 over square root of 2, square root of 3 over 1. That's it. That's all you can get. Okay, so you'll see the same answers many times and be able to jump to the fact that it will be square root of 3 over 3 when I see this. Okay, if you choose to not go hand trick route and you do like memorize, we would have been looking at pi over 6. It is 1 square root of 3 over 2 comma 1/2. And I have to do y over x, or sine value over cosine value. This is where you have to remember that tangent is sine over cosine, which is 1/2 over the square root of 3 over 2, multiplied by the reciprocal. That's the same exact one we just did a couple slides ago. Questions? Or I do my special right triangle with a pi over 6. And I would do opposite over adjacent, which puts you back here. Questions? Okay. I'm not going to talk for a minute. Let you try this one. Try out a method. Okay, shall we see how we did? See if your method worked for you. First of all, drawing 5 pi over 6. 6 over 6 is half a circle. 5 is 1 short of that. I should have landed into quadrant 2. My reference angle is pi over 6. I am doing a sign problem, which happens to be the only thing positive in quadrant 2, so my answer is going to be positive. That last comment that I just made is going to be probably the #1 thing that people miss, is putting the correct positive negatives on there. Forgetting to put a negative on really is what's going to happen. Don't forget to think through that part, the all students take calc part. If I am a hand trick person, my reference angle is pi over 6. Remember, small to big, pi over 6, pi over 4, pi over 3. So pi over 6 goes alphabetical order, cosine fingers, comma, sine fingers. I have 1 sine finger, square root of fingers over 2. How do we do? Get 1/2? Good. Good. If I did my memorize quadrant 1, so I can stop drawing this a million times, I would have said, okay, my angle is pi over 6, cosine is my second number. Okay. If I am a special right triangles person, I would have drawn my model for the 30, 60, 90 here. Pi over 6 is here. Opposite over hypotenuse. Pick your method. Okay. All right. The last thing that we are going to talk about right here is, okay, what happens when it's on an axis? We've had our intro to this, but now we're going to make it official. I am telling you that in the unit circle, R is 1, which means our length from the origin to each of these points is 1. You've seen me draw this up here more than once, right? Okay. So now we, again, a little more official is that I know each of those ordered pairs goes my cosine value, comma, sine value. And that if I'm asked for my tangent, it is always my sine over cosine, which would be my y value over my x value for each of those ordered pairs. What will put me on an axis in degrees: 0, 90, 180, 270, 360, and any multiple positive or negative of 90, right? In radians, it is our pi over 2s, 1 pi over 2, 2 pi over 2, which simplifies to pi, 3 pi over 2, 4 pi over 2, which is the same as 2 pi. And then I can keep adding pi over 2s if it goes past a full circle, right? Find my correct place. And again, we've kind of already seen an intro to this, which is nice, but I will remind you that the only possibilities on a quadrant or on a quadrantial angle on an axis is 1, -1, 0, and undefined, right? Just a quick reminder, 0 over 1 is 0, 1 over 0 is undefined. That can happen when we're doing tangent, right? Sine over cosine can give us a fraction. Otherwise, it's, okay, we're going to do one here. Otherwise, it's just looking at this. Some people get bothered because it seems like it's not enough work. What if I asked you for the cosine of pi? I find that cosine is the first number. My answer is -1. No work to be done. Questions? So let's do tangent of 270. Those questions kind of become moot, not needed, when we fall on an axis, because there isn't a reference angle, there isn't a quadrant. The question becomes, what's the ordered pair on that dot? So 270, we figure out which axis and what's the ordered pair. How would I get there? I would go right or left 0, down 1. Then I remember the fact that tangent is sine over cosine. Cosine, comma, sine, right? Alphabetical order in our ordered pair. And so I would put my sine value for tangent of 270 is sine over cosine, which I cannot leave, and -1 over 0 is undefined. Questions? Okay, so here's my advice to you. As you sit down to do unit circle questions, as we are learning these first values, I would draw a couple things for myself on these early assignments. Actually, I'll probably continue drawing them on everything. One of those is this picture, but some of you will get past needing to see this. You'll be able to just visualize it in your head. And then whatever your method is, if that means you're going to go draw a quadrant 1 on the top of your page, do that. If that means that you're going to go draw your 2 special right triangle models, do that. Or if you need to like put just like which finger is which, because that's my hand trick people, that's what you're probably going to need to practice is, oh, which one is the pi over 3 finger? Okay. That's probably what you're going to start by drawing so that you can have that quick reference. You don't want to draw it every problem. Do you feel like you have a method that you can try out? Okay. You do have a worksheet today. Oops. And I do want to talk about one problem on your worksheet. Actually, 2 sections on your worksheet before I release you to work.